everybody, let's talk about limiting reactants. So, a limiting reactant is a reactant, that is totally consumed when a chemical reaction is completed. So what does this actually mean? It is some reactant, some starting material that gets used up first in a chemical reaction. It is the reactant, it is the species that really drives how much product you can make, because once your limiting reactant gets used up, it stops the reaction. If it's used up, you can't produce anything else because one of your reactants has already been totally consumed. The other reactant, or reactants, if you have multiple, would be found to be what's called in excess, because they did not get totally used up in the reaction. You have excess of them available to you. You can abbreviate this INXS to tell people which reactant is in excess, which coincidentally is also an 80s band. So let's think about this in terms of something that we've already looked at, something like s'mores. So if we were going to make s'mores, we need 2 graham crackers, we need 3 pieces of chocolate, and we need a marshmallow. So let's say you and a buddy want to make some s'mores. You go to grab all the materials. You are going to need 4 graham crackers total. You've got 4 graham crackers. Excellent. You're going to need 6 pieces of chocolate. You've got 6 pieces of chocolate. Great. And then you go to your bag of marshmallows, and you only have 1 marshmallow left. What's going to happen? Well, somebody's going to get their s'more, and the other person is not going to get a marshmallow, which means they can't make a s'more, and everybody's sad. So, your marshmallow in this scenario is your limiting reactant. It's the thing that's preventing you from making more s'mores. It got used up first, there's nothing left. Even though you have enough graham crackers and enough chocolate, you can't make any more s'mores because you've used up all the marshmallows that you have. You used up one of your reactants. Your graham crackers and your chocolate then would be in excess because you have more of them. You have extras available, but you can't do anything about continuing your reaction. So we can determine what a limiting reactant in a problem is in a couple of different ways, depending on what information you're given. One of those ways is by using a particulate diagram. So we're going to do that in this video first. We're going to take a look at particulate diagrams to determine a limiting reactant and excess reactant in a chemical reaction equation. So if we're taking a look at this example right here, this is the reaction of gaseous carbon and gaseous sulfur, and these two things are going to react together to make carbon disulfide. So to figure out your limiting reactant, there's a couple ways you can do it. I'm going to show you 2. Step 1, you're going to take an inventory. We're going to count your particles in each diagram and list them in the table. How many do we have before? How many do we have after? So let's start out with carbon. Before, I have 1, 2, 3, 4, 5, 6 carbon atoms, elemental carbon atoms. Now if I take a look at sulfur, I have 1, 2, 3, 4 sulfur atoms. Great, awesome, wonderful. Now I mix these things together and a reaction happens. What do I get at the end of it? Well, I get some carbon disulfide. I get 2 carbon disulfide molecules. But look at this, I have a bunch of carbon atoms still at the end as well. So I'm going to count those up right here and put 4. The other way that you could help yourself keep inventory is you can cross things off. So I know that to make 1 carbon disulfide molecule, it looks like I need a carbon. So I'm going to cross off my carbon left and right, accounting for that being the same carbon. I need 2 sulfurs, so I'm going to cross off 2 sulfurs right there, accounting for that, making that 1 molecule. Then I need another carbon, and 2 more sulfurs, and now I've got a bunch of leftover carbons floating around, so I'm going to leave those as is. So which reactant is in excess? Well, if I look at my diagram, what's the one reactant that I still have left over at the end of this reaction equation? I have a bunch of carbon left over. So carbon must be my excess reactant. Which reactant is going to be limiting? It's the one that got used up first. So in this reaction, I don't have any sulfur left over. All my sulfur got used up and got put into a new form, the form of the carbon disulfide molecule. So this means it must be our limiting reactant. So let's think about how we can translate this into a chemical reaction equation. A chemical reaction equation indicates your lowest whole number ratio of reactants and products. What's the minimum amount of things that I need to react together to get the product that I want? If we're thinking about s'mores, the minimum amount of stuff I need is I need 2 graham crackers, 1 marshmallow, and 3 chocolate pieces. Anything less than that, and I can't even make a singular s'more. So a chemical reaction equation, a balanced chemical reaction equation, is a statement that tells us how our reactants are going to combine together and how many products can we make when we have the minimum amount of supplies. They don't depend on masses of reactants. They depend on moles of reactants. How many moles of particles do we need to get these things to react? So we don't care about the masses, we care about the moles, but also our leftovers at the end, we don't care about those either. We just need to have enough stuff available to make this reaction happen. So whatever our excess reactant is, it doesn't get represented on the product side of the reaction equation. So let's think about how we can represent this carbon disulfide reaction to indicate how our reactants are combining to produce this product. So I can start out by thinking, how many carbon disulfide molecules did I make at the end? Well, I have this one and I have this one. In each carbon disulfide molecule, I have 1 carbon and I have 2 sulfurs. So if I write that as a product, that looks like 1 carbon bonded to 2 sulfurs, and I made 2 of them at the end. How did I make that? What were my reactants I started out with? Well, to do that, I needed 1, 2, 3, 4 sulfurs. So I needed 4 sulfurs. And I needed 1, 2 carbons. So 4 sulfurs plus 2 carbons gave me 2 carbon disulfides. But if we look at these coefficients here, I can reduce. I can divide everything by 2. So when I do that, I get 2S plus C yields CS2. What this is showing me is the balanced chemical reaction equation I want. This is the minimum amount of supplies that I needed to make this reaction happen. For every 1 carbon, I needed 2 sulfurs to make 1 carbon disulfide molecule. So you always want to make sure that your equation is reduced as much as possible. But notice at the end here, like I said earlier, I don't put plus C at the end. I don't care that carbon is my excess reactant. It doesn't get represented as a product because it's not changing. In a chemical reaction equation, you have to have something new that wasn't there before. And if my carbon is the same before and after, nothing about it has changed. It's just an excess reactant. So it doesn't get represented in the reaction equation here. So this is my final answer. Woo!